Hello everybody, my name is Prantic and this is my reflective presentation on what I learned from completing my research report, which was on advanced sensor technology for tunnel monitoring. At first, I thought that this topic would mainly involve explaining instruments, such as piezometers, inclinometers, automated total stations, and fiber optic sensors. However, as I worked through the research, I realized that the stronger engineering focus was not on the sensors themselves, but rather on how sensor data supports decisions during tunneling. So the main idea of my report became advanced sensors are most valuable when they are connected to engineering judgment and clear response actions. One key thing that I learned is that tunnel monitoring is needed because underground construction is essentially uncertain. Even with a good design, actual ground response can change because of soil conditions, groundwater, face pressure, grouting, support timing, and nearby structures. This is especially important in urban tunneling, where small movements can affect buildings, rail corridors, utilities, or existing tunnels. So I learned that monitoring is not just about collecting data. Its real value is in early warning, so that engineers can respond before a small issue becomes serious. And so the biggest change in my thinking was moving away from a device-based view to a decision-based view. Instead of only asking, what does this sensor measure? I started asking, what decision does this sensor support? For example, settlement markers and automated total station prisms help identify asset movement. Piezometers help assess groundwater risk. Strain gauges and fiber optics help assess lining or support behavior. This helped me understand that monitoring becomes advanced when the data is connected to baselines, thresholds, interpretation, and action. And so the main challenge was narrowing down the topic. Advanced sensor technology includes instruments such as telemetry, fiber optics, digital twins, AI, standards, and case studies. And because of that, the report could have easily have become a catalog of technologies. To avoid this, I focused on engineering value, such as risk detection, construction control, asset protection, and lining performance. And the case studies, they helped me focus the argument. Crossrail showed the importance of installation quality. Barcelona Metro Line 9 showed the value of fiber optic sensing. And Sydney Metro showed the importance of governance, baseline readings, and alert action systems. So ultimately, this task was professionally relevant because it showed me that civil engineering is not just about technical information. Rather, it's about making responsible decisions under uncertainty. Advanced sensors can provide more data, but they do not replace engineering judgment. Engineers will still have to decide whether the data is reliable, whether the trend matters, and decide what response is needed. And if I were to improve my research further, I would have included more project-specific measured data, more quantitative comparison between sensor technologies such as accuracy, cost, sampling, frequency, and maintenance. But overall, the main lesson I took from this task is that tunnel monitoring should be designed around decisions, not devices. Advanced sensors are useful when they help engineers know sooner, decide better, and act before uncertainty becomes real damage. And to conclude, I just want to thank you all for your time today. It has been a pleasure giving this presentation. Thank you.